Hi, I hope everyone is doing well. In today's video, we'll be going through distance time graphs. Have a pen and paper ready to take down some notes. Make sure to stick around to the end as there are some questions for you to attempt. And if you want to find your way back to the channel, make sure to subscribe to stay up to date with everything related to your Maths GCSE. Let's get started. So what are distance time graphs? A distance time graph plots the distance an object travels against the time it takes it to travel. What you need to understand is that in a distance time graph, the horizontal axis shows time and the vertical axis shows the distance. So along the horizontal axis we'll have time, and along the vertical axis we will have distance. We'll use this graph to plot the distance an object travels against the time it takes it to travel. There are three main types of lines that will occur if we have this distance time graph. If you have a line like this going up, this is what we would say is a constant speed. So this line indicates that our object is going at a constant speed away from our starting point. If we have a horizontal line like this, this means that this object at this given time is stationary. What that means is that it is not moving. The final type of line that we will look at is the one that is decreasing like this, and this is returning. So this object is returning back to the starting point. What you need to include in any distance time graph is a title, labels on each axis, and ensure you go up in equal measurements at equal distances apart. Over the next few slides, we'll go through some examples. Let's go through an example. So what does this graph show? So we've been given a distance time graph. It has already been plotted for us, and we can use this information about the lines to describe the journey. So for this first line, this will indicate an object moves at a constant speed from its starting position. This point of 0, 0 was the starting position. The object has a constant speed and it is moving away from the starting position. The next line that we have is this horizontal line, and this means that this object is stationary, i.e. it stopped, so it is not moving. Next we have another incline, which means that it moves further away from its starting position. And then finally we have this decline line, which indicates it returns to its starting position traveling at a constant speed. So basically when the line is going up, it is getting further away from the starting position. When the line is horizontal, the object is not moving. And then when the line is decreasing like this and it touches this horizontal line, it means we have returned back to our starting position. Let's go through what we have learned on the previous slide and put it into practice. So the following distance time graph shows a car's journey. So our object is a car. We have been given this distance time graph. The distance is measured in meters and the time is measured in seconds. How far did the car travel in the first 3 seconds? So what you will look at is you go to where it says 3 seconds, you will draw a line up. Where it touches the line, you will draw a horizontal line going to distance, and this indicates that it has traveled 60 meters. Another type of question, how long was the car stationary for? So we know that this horizontal line indicates that the car was stationary. We can see that it was stationary from 3 seconds up until 5 seconds, and the difference between 3 seconds and 5 seconds is 2 seconds. So the car was stationary for 2 seconds. How far did the car travel in total? So what you need to understand is that the car traveled up until this point and it was 100 meters. So it traveled 100 meters going in one direction, and then the car returned going back to our starting position, which is another 100 meters. So it traveled 100 meters in one direction and 100 meters coming back to its original starting position. Therefore, it traveled 200 meters in total. Let's go through another example. The following distance time graph shows a cyclist journey. So the object is a cyclist. The distance in this example is measured in miles and the time is measured in hours. How far did the cyclist travel in the first 5 hours? What you do is draw a line at 5 hours and you will go across until it hits distance. And as you can see, this mark is between 60 and 40. So this will be 50 miles. So how far did the cyclist travel in the first 5 hours? We would say it is 50 miles. The next question, how long was the cyclist stationary for in total? So it says in total. So he was stationary from this point to this point, which is 1 hour, and it was stationary from this point to this point, which is 3 hours. Therefore, he was stationary in total for 4 hours. The final question, how far did the cyclist travel in total? As you can see, he traveled up until this point, which is 50 miles. And then the cyclist returned back to his starting position, which is an extra 50 miles. So altogether, he traveled 100 miles. Another type of question it will ask you for is the average speed. For us to work out the average speed, we need to use a distance, speed, and time triangle. So at the top of this triangle, we'll put D, which stands for distance. In the bottom left, we'll put S, which stands for speed. And in the bottom right, we'll put T, which stands for time. So DST. So this is the distance, speed, time triangle. If you want to work out the speed, it is distance divided by time. If we have this example, we have distance equals 130 miles. The speed is what we're trying to work out. And the time it took is 2 hours. So we are saying that it took us 2 hours to travel 130 miles. If you want to work out the average speed, what you would do is the distance, which is 130, divided by the time, which is 2 hours. Therefore, the speed is 65 miles per hour. So every hour we traveled 65 miles. If we want to work out the distance is speed multiplied by time. So for example, we're trying to work out the distance. The speed is 13 kilometers per hour and the time is 3 hours. So we would say that the distance is equal to 13 kilometers per hour times 3 hours. Therefore, the answer is 39 kilometers. So the distance that we traveled is 39 kilometers. Finally, if we want to work out time, you would do distance divided by speed. So we have at this example, we have the distance equals 48 meters. The speed is 4 meters per second. What is the time? The time would be the distance, which is 48, divided by the speed, which is 4 meters per second. You'll get an answer of 12 seconds. Hopefully you should understand this from previous knowledge, but if you didn't, hopefully this is a good recap. So let's go back to one of our previous examples. So the following distance time graph shows a car's journey. What we are asked for now is what was the speed of the car for the first 3 seconds. So we are looking for the speed or the average speed for the car for the first 3 seconds. What we need to remember is that the speed is equal to the distance divided by the time. So the distance in this example is 60 and the time is 3 seconds. So what you would do is you would do 60 meters because we're working in meters divided by the time, which is 3 seconds. So therefore the speed is equal to 20 meters per second. So all you're basically doing is finding the distance, dividing it by the time, and that is going to give us the speed. Let's go through another example. The following distance time graph shows a cyclist's journey. Again, we have time, which is in hours. We have the distance, which is in miles. What was the speed of the cyclist for the first 5 hours? Again, what you would do is we know that the speed is equal to distance divided by time. So we need the distance and we need the time, both of which we have in this distance time graph. So you look at this value, which is 50 miles, divided by the time, which is 5 hours. So the speed is equal to 50 miles divided by 5 hours. Therefore, we are doing 50 divided by 5, which is equal to 10 miles per hour. So every hour you are traveling 10 miles. Another example, what was the average speed on the return home? So we know that the return home is from this point to this point. Again, we need the distance and we need the time. As you can see, the distance from this point to this point was 50 miles and the time it took us was 2 hours. So we do 50 divided by 2, which is equal to 25 miles per hour. Here are some questions for you to attempt. Please pause the video, have a go, and we'll go through the answers on the next slide. Hopefully you had a chance to attempt the questions. Let's go through the answers. The graph shows a cyclist's journey from home to another city and back. So we have been given this graph. How long in total was the cyclist stationary during his journey? What you need to remember is that when it is horizontal, that indicates that he is stationary. So from this point to this point is half an hour. From this point to this point, again, it is horizontal and it goes from 3 to 4. So that is 1 hour. So in total, he was stationary for 1 hour and 30 minutes. How far did the cyclist travel in total? So again, from this point to this point, he traveled 35 miles. And from this point to this point is another 35 miles. So in total, he traveled 70 miles. 35 miles going away from his home, and then 35 miles going back to his home. What was the cyclist's speed on the way home? So the speed is distance divided by time. We know that the distance back home was 35 miles, and it took him 2.5 hours. So 35 divided by 2.5 is equal to 14 miles per hour. So the cyclist's speed on the way home was 14 miles per hour. What was the cyclist's greatest speed? So what you need to know about these slopes is that the higher the gradient, the faster the speed. So this line has the highest gradient. From this point to this point is 20. So from 15 to 35 is 20. And you divide it by the time. So it's 1 hour. So it's 20 divided by 1, which gives us a final answer of 20 miles per hour. This is a summary of what we have gone through today. We have gone through what a distance time graph is. We know that on a distance time graph, the horizontal axis shows us the time and the vertical axis shows us the distance as shown above. And we have also gone through the distance, speed, time triangle. I hope you have been able to benefit, and if you have, please share with others so they can also benefit. Hopefully I'll see everyone safe and sound for the next one, and as always, take care of yourselves.